Hello, my name is Christopher. In this video, I'm going to talk about the different focus sequences that UCSD offers to structural engineers, what they entail, where they are useful, and the different jobs available for each one. Stay till the end of the video to see which is my favorite focus sequence and why. Number 1, civil structures. Probably the most popular sequence at UCSD. The civil structures focus sequence entails all structures related to civilian usage, such as buildings, bridges, and highways. Civil structures are vital for human functioning, whether it is to facilitate transportation or habitancy. The world would not be the same without civil structures. Structural engineers that choose the civil focus sequence can work on the design and planning of structures. Some even get the opportunity to go out to the field and supervise a project. Moreover, civil structural engineers can choose diverse career paths that involve other subjects like management, consulting, and even business. Number 2, geotech. This is probably the most underrated sequence out of the 4. The geotechnical focus sequence covers what would be the analysis and design of the foundation of all on-land structures. Geotechnical structural engineers are masters of soil, which is often thought of as a mixture of organic matter that is composed of 3 different components: solids, water, and air. Geotechnical structural engineers are just as important as civil engineers because they ensure that the earth conditions of the land on which a structure is going to be built is suitable for the desired type of project. Coincidentally, as a geotech master, you could work not only on the foundation of civil structures, but also on other non-civil structures such as dams and ports. Number 3, aerospace. Rockets, airplanes, satellites, you name it. The aerospace focus sequence emphasizes the design and analysis of all aerial high-performance structures. As an aerospace structural engineer student at UCSD, you'll be learning how to use CAD software to develop aerospace structures, and you'll learn about composites, which are complex, fancy, and highly resistant materials used in many different fields, including the aerospace industry. As an aerospace structural engineer, you could get a job in an aerospace agency such as Boeing or SpaceX. However, you could also end up in the automobile industry, working for a government agency such as General Atomics, or even design and develop race drones for competitions. Number 4, structural health monitoring. One of the least known focus sequences. The structural health monitoring focus sequence is all about analyzing living structures in order to execute repairs or just prevent disasters due to fatigue. It's important to not get non-destructive evaluation, or NDE, with SHM mixed up. They are similar, but the key difference is that SHM is a type of system that is actively being implemented, while NDE is more of a test performed, a one-time thing in a sense. As mentioned before, students in the SHM focus sequence will execute tests and analysis with the help of software in order to obtain substantial information about the state or health of a structure. As an SHM structural engineer, you will work on the collection of data, which is then utilized to define what type of damage is detected, the severity, and even the location. Interestingly, SHM is needed in a lot of fields, but it is substantial in the aerospace industry. Finally, if you made it to this part of the video, it means that I get a chance to tell you which focus sequence I chose and why. To be honest, when I applied to UCSD, I knew that I wanted to major in structural engineering because I liked civil structures, design, and engineering. However, it wasn't until my first orientation and after some digging that I realized the school offered different focus sequences. That was when I decided to switch from the civil to aerospace structures focus sequence because I am much more passionate about astrophysics, rocket science, and high-performance vehicles than about safety and big-scale structures. Alright, so that's all for today's video. Thanks for watching.